Hi guys, I'd like to welcome all of us to my channel of Honesty Sciences and Mathematics TV channel. In this specific discussion, we're going to look at the concept of geometry, and that is the angle bisectors. Now, in our previous videos, we had looked at the concept of perpendicular bisectors, and of course, I had talked about two specific aspects for perpendicular bisectors and bisectors of what we refer to as triangles. So in this specific case, I give two specific examples for lines of I and M. Right, you can just rather give them as I and M given as such. We say that for lines I and M to be regarded as perpendicular to one another, we're going to have this specific angle, which is at this particular point, or which is the point of intersection, having the stretch of 90 degrees in this specific illustration. So therefore, we can be able to say that this specific stretch for x, y over 90 degrees gives this aspect of line I being perpendicular to line M given as such. So if we have two specific rays, which is point R and point S, and point P perhaps at that specific point, we're going to see that a perpendicular bisector that is going to divide this specific segment SR is going to divide this segment along this specific line, and that is going to form a 90 degrees angle, and we can be able to describe this segment S4 as equivalent to OR respectively. And similarly, we can be able to describe a line that is going to be or a segment that is going to be formed between this particular point SP and SR, whereby SP is going to be equivalent to SR respectively. And then next we said that we can be able to give other characteristic of this specific perpendicular bisectors, whereby the angle R or the angle POS is going to be equivalent to angle. So this angle POS is going to be equivalent to POR, which are going to be 90 degrees. So therefore, this is going to describe the perpendicular bisector insofar as lines are concerned. And then we said that we can be able to describe an perpendicular bisector of a specific triangle, whereby we see that for triangle ABC, the specific perpendicular bisectors are going to divide these specific lines or line segments, the three segments for a triangle, into equal parts, whereby this one is going to be equivalent to this one. And then we're going to have another perpendicular bisector dividing this angle, this one equivalent to this one. And then we're going to have another perpendicular bisector dividing this CB segment, CB at this specific point. So this is going to be perpendicular. This is going to be perpendicular. And this one is going to be equivalent. So this one is going to be equivalent from this specific point. So suppose I give a perpendicular bisector of a segment AB at the point M, and the perpendicular bisector of a segment CB at the point N, and perpendicular bisector of a segment AC at point P, then we're going to have this particular point of intersection, which is Q, formed at that specific point. And in our last discussion, we described this particular point as a circumcenter, and this is the point which is going to be forming a circle that is going to go through the three different vertices given as such. So therefore, that is why we describe this one as a circumcenter, and we say that this specific triangle, of course, is going to be circumscribed, or this specific what we refer to as circle is going to be circumscribed, of course, around the triangle. So this is going to be the only point that is going to go through the three vertices, as we said. And of course, we said that one of the characteristics of this specific center is that it surrounds the triangle given as such, and it's going to be this particular point is Q is going to be equidistant from the three vertices of A, B, and C given as such. So in this specific discussion for angle bisectors, then therefore we're going to look at a unique case whereby we're going to bisect these individual angles A, B, and C. And in that particular case, I refer to angle CAB for angle A, ABC for angle B, and ACB for angle C, respectively. So I'm going to give a different illustration for this specific case so that we can be able to understand this concept of angle bisectors. So suppose I have a triangle which is given as a triangle ABC. So triangle ABC consists of three angles, which is this one, angle B, angle A, and then of course I'm going to give this one as angle C respectively. Now in this particular case I refer to angle ABC. The center point is the one I'm referring to as an angle. So suppose I do a division, or I bisect this specific angles at the center like that. I'm going to have this specific perpendicular bisectors running through those various points given as such. So they are going to divide this angle C into two equal parts for this one and this one. And this is going to divide as well this one into two equal parts. And this one is going to be divided into two equal parts as well. So suppose I give these perpendicular bisectors for angle B as P, for angle C as S, and for angle A as R. So the perpendicular bisectors S, RP are going to be, of course, forming a common point. And this point that I'm going to give perhaps as O is going to be referred to as the common point that I've referred to as an in-circle or in-center. So this point, common point over this perpendicular bisectors, is going to be referred to as an in-center. And this, of course, is going to be the center of a circle that is going to be described in this triangle. So suppose we draw a circle, and therefore it's going to touch on these specific parts or a segment of this specific circle, whereby a point from the center O to this particular point of a segment is going to form the radius of that specific circle. So the three angles bisectors are going to go through the same point, and of course this is going to be the center of the inscribed circle given as such. So this is also one of the characteristics of angle bisectors that we're going to see being displayed insofar as triangles are concerned. And of course we're going to see other various aspects of geometry which are going to be displayed by bisectors, perhaps perpendicular bisectors, angle bisectors, and the bisectors of a segment in that specific order. So check our description boxes for various links of other videos, and kindly check, subscribe to our channel so that you can be getting updates on various other topics, either in mathematics, physics, chemistry, and biology. So that is it for now, guys. Bye. Catch us in our next video. God bless you.